So we've seen that when you are trying to solve an equation that has an exponential expression, you use logs. I hope it comes as no big shock then that when we have an equation that starts with logs, you're going to use exponentials to get that equation solved. Notice the steps here, they are pretty much the same as before with just, of course, that little tweak. You're still going to start with isolation, get the log by itself. So let's do that here with this example. What we mean by that is this part, the log base 4 of b, has to be on one side of the equation with nothing else there. No plus, minus, multiply, or divide. That means this negative 8's got to go. It's currently negative 8 times the log, so do a division by negative 8, both sides. That's going to leave us with log base 4 of b, the variable we're solving for, and negative 8 divided over here is going to give us a 2. So isolate the log, it's now by itself. It's just log base 4 of b. Change to exponential form, so 4 to the power of 2 equals b. Solve what remains. Sometimes there may be something left to solve. This time there's not really. 4 to the second, that's just 16, so we evaluate it. And there you go. This one's all finished. Now I'm giving it a highlight, but we should, of course, check that answer. And here's the thing. Check on any calculator. If you're going to use a scientific, you can use your change of base. I'm going to use the Desmos just because it's a little easier to type in that additional base. You can also do that on the handheld TI. But go back to your original equation. So I think b is 16. So if I come here and I do negative 8 log and then underscore base 4 of the number 16, I hope I come up with a negative 16 as a result. We did. We have solved that equation properly. Please don't make that complicated. Get the log by itself, switch to exponential form, and then evaluate what's left. All right, next up, please give this one a look. A quick pause, unpause when you are ready to check. In this case, log's already by itself. So some of you have asked, how do you know what's inside the log and what's not? If there's parentheses, that clearly shows you what's in the log. If there's no parentheses, you assume it is the term immediately following the log. So that is a coefficient and a variable. That's a term. So this is inside the logarithm. The log is already by itself. Switch now to your exponential form. So 5 to the power of 3 equals 6x. So 5 to the power of 3 is 5 times 5 times 5. That's 125. And now solve what's left. I don't want 6x. I want just x. So divide by 6. So the x we end up with then is 125 divided by 6. If you also want to get a decimal approximation, you can. So if I go here and do 125 divided by 6, it's not going to come out evenly. So it's about 20.8333. Notice because I'm using it rounded, I'm switching over to that approximate symbol. So equals means they're exactly the same. The little squiggles mean, well, we're close to the same, but we rounded. We should, of course, check this answer. Go back to your original equation. And when you're checking, I'm going to recommend using the unrounded answer if you have the choice, which we do here. So it was log, do the underscore 5 of 6 times the variable, which I think is 125 divided by 6. The result ends up being 3, which is what we want the result to be. So we have done good. Let's give that a highlight and call it fantastically done. Okay, once more, would you please do a quick pause? Unpause when you're ready to check. Just to make it a little easier to see what's going on. Again, when there's no parentheses, it's that term that is immediately after. So a coefficient and variable, that's a term. So the log is not isolated. It's got this 10 in front. So a division by 10 first. So log base 2 of negative 4p is negative 2. Now you're ready to switch to your log form. So 2 to the power of negative 2 equals negative 4p. Now here you got some choices as to what's easiest. You can turn this into a decimal. You can turn this into a fraction. Just know that 2 to the second is 4. So 2 to the negative second is 4 reciprocated. So 1 over 4 equals negative 4p. Now, to get the p by itself, divide by negative 4. That's the same as, and I need you to know this, that's the same as multiplying by negative 1 over 4. Those reduce, you still get the p by itself. And then over here, it's maybe a little easier to see where you end up. So multiply negative times positive is negative. 1 on the top, 4 times 4 is 16 on the bottom. There you go. Now, if you get that as a decimal, it's still okay. I don't know my 16ths. It comes out to something. So then, let's give it a check. I think negative 1/16 is p. So I go back to my original equation, 10 log base 2 of negative 4 times the p, which I think is negative 1/16. We want to end up with negative 20, and sure enough, we did. So the process, quick recap to wrap up. Get that log by itself. Once that's done, switch to your exponential form, and then solve what remains.